Hi, I'm Ilya Shishkov. I work at Yandex and I'm a member of ICPC Analytics Analytics team. And I want to tell you how to solve problem E. In this problem we have an axis, and at the beginning all the heights of this axis are equal to 0, and we have 4 operations that we can do. These operations, one of them is raise. It increases by 1 heights on the given range. It gets 2 boundaries. Also there is an operation D which makes the same in the opposite direction. It lowers the heights of the elements on the range. And also we have H and V, which create, the first one create a hill and another one create a valley, which increases height of the first element by 1, of the second by 2, and so on. So we have a number of these operations, and our goal is to calculate the result height of every position on our line. So we want to know for every E height of E. So let's talk about how to solve it. The first trick we can do is that we can reduce the amount of operations. We can represent operations R and D, which increase height and decrease height by 1. We can represent them as one hill and one value. So raise is hill and a value, a valley, this way. So range LR is H hill LR and valley L plus 1 R minus 1. So now we have only 2 operations, H and valley, and we understand that they are symmetric, so we can just implement one operation hill, and valley is the opposite. So the next thing we can do is represent hill as 2 lines, this one and this one. Okay, so now we should be able to apply a line to our array of heights. Suppose that there is an array height, eta, and when we apply the first part of our hill, what we do, we have operation H, L, and R. We do height L plus 1, height L plus 1 plus 2, and so on. This is not easy to do if you do it straightforward, but we can look at the first derivative of the heights of our items, and in this case, when we want to apply the raise, then let's call this derivative dh. Then when we apply this line, how we change our items. For the L we do plus 1, for the L plus 1 we do not plus 2 but also +1, and so on. For R, we do also +1. When we apply these operations, then we can just calculate prefix sums of dh, and the result of these prefix sums will be the answer. To implement these array increases by 1, we can use a segment tree. Or we can do another trick. We can calculate second derivative of our array height. When we do this, then applying this line for the second derivative, let's call it dh2, means that we can just increase L by 1, and we can decrease R by 1. So this avoids implementing segment tree, and the solution is as follows. We read all our operations, represent them as hills and valleys, and we maintain this array dh second and apply the operations by raising and lowering segments. And after that, we calculate prefix sums of dh second. We get dh, and after that we calculate prefix sums of dh, and prefix sums of dh is our answer. That's it. Thank you.